You ready? Highlighters?
17.
17. Yeah. Let's go for a ride here. Stating the maximum and minimum. Okay? And I think you're going to catch some of the things you missed if you pay attention. I'm going to repeat that today. So we're not going anywhere. Precision uncertainty is very important to understand, right? Once we state the measurement, plus or minus its uncertainty, right? Once you have this, because you always measure something and then it's like, hey, I could be off by a certain amount. Once we have this, we are actually saying that the measurement can be above, right? That's what we call the max, or below, which is what we call the min, the target measurement. In general, I'm going to highlight two things here. In general, right, your max, if you want to get the max or the greatest possible measurement, we take the measurement and add the uncertainty. If you want to get the minimum, you take the smallest possible measurement and you subtract the uncertainty from it. That's basically what it comes down to. Right? Remember, measurement plus or minus uncertainty. It's a little blurry. Is it just my vision? I feel like I need to get my eyes checked. I'm having a harder time reading these days. The thermostat in Mr. D's classroom is set to 72 degrees. A lot of these pictures are actual things that I found. I just went around at home. Everywhere I went, just took pictures of actual things that measure stuff, right? And so my thermostat, right? Let's say it says 72 degrees in this room. Do you think it's exactly 72 degrees in this room? Could it be 71.9? But that thing, right? That device cannot do it. It can only tell you to the nearest degree what the temperature is in here. It could also be that it's 72.4, 72.1. Like it could vary up and down. But right now, based on this, right, I always tell students, imagine this is what's on your screen. And based on what you see here, it could be 73, but it could also be 71. So you can tell that your precision is 1 degree. In this case, it's Fahrenheit. Is there somewhere a Fahrenheit? It doesn't say it, but this is Fahrenheit, okay? So state the measurement plus or minus its uncertainty. Before we do anything, we state that the precision in this case is 1 degree Fahrenheit. You need to get your precision before you get your uncertainty. So hey, if this thing is precise to the nearest degree, that means that, right, 1 divided by 2, that the uncertainty in this case is 0.5 degrees Fahrenheit. Okay. So now this was important to us. We needed this portion and we figured it out. But it all came back to figuring out the precision first and foremost. Okay? Got it? So now we go back to this and say, like, hey, the measurement is 72 degrees Fahrenheit plus or minus 0.5 degrees Fahrenheit. This is what the question is asking. In fact, in this unit, every time you try to measure something, you're gonna tack on plus or minus, right? That's just standard in this unit. That's what we do, okay? So the measurement itself, we got it from right here, okay? That's like what the device reads. Sometimes you have to read, right? If you're using a measuring tape, you are the one determining, it's like, this is what it is. In this case, you don't have a choice. You just got to go by what the thermostat is showing you, right? Okay, let's stick with the plan, right? The uncertainty is there, right? So we figured out the precision, which notice that the precision doesn't show up here anymore, right? But we needed it to figure out the uncertainty, which we can then tack on, okay? Once you have this, right? This is saying you could be above or below. There's a max and a min temperature, right? So state the maximum and minimum temperature in the room. So the max would be 72 plus 0.5. And I picked nice and easy numbers here, right? But you could have 3, 4 decimals easy, right? 72 minus 0.5. So when you apply the uncertainty, you could see that you could tell that the highest temperature in this room could be actually 72.5, and the lowest temperature in this room could be 71.5 degrees Fahrenheit. So that's what it's saying. It's like there's a highest, there's a lowest. And so that's what it is. Before I do this one, I just thought of a joke, okay? Ready? Why did the garden turn down a date? Because she had other plans. Anyways, if Mr. D has plants in the room that need a room temperature of at least 65 degrees Fahrenheit, some of you are just, it's Monday morning, right? It takes a while. It would be a good idea to set the thermostat to would it be a good idea to set it to exactly 65 degrees Fahrenheit? Explain using your knowledge of precision and uncertainty. Would it be, if it says, hey, you need exactly 65 Fahrenheit, would it be a good idea to set it to exactly 65? So let's just say this. Technically, based on this thermostat, it's 65 plus or minus 0.5, right? So there's a max temperature and there's a min if you set it to that. It could be as low as 64.5 degrees Fahrenheit, or if you add these up, as high as 65.5 degrees Fahrenheit. This is below the lowest acceptable temperature. So it would not be a good idea. You should set it to 66 at least, right? It would be better to set it to 66 degrees Fahrenheit. This accounts for the uncertainty. Trust me, it says uncertainty. So I'm trying to get you to think of like what's that uncertainty, right? But there is your thermostat in your house. If it says 72 on it or 22, let's say you have set it to Celsius, then a lot of people have it in the 20s, right? When it feels kind of cold in the house, right? It's probably getting just closer to 21, and that's when the furnace is going to kick in, and it probably heats it up to 23, not 22. Even though you have to set it to 22, it probably heats it a bit higher and then turns off, lets it cool down, goes a little bit below 22, and then it turns on again. So there's always some fluctuation, right? Otherwise the furnace would have to go every second, right? Let's keep going. Backside here. I don't know. I feel like I need to review how to use your rulers because every time I assume you know, it backfires. Some of you haven't used it in a while, or anyways. So obviously this ruler here is in centimeters, but what are the smallest markings here? Smallest increments, right? Let's do this. Watch. If you were to count the number of marks from 0 to 1, there are 10 millimeters, correct? So you can say 10, 20, 30, 40. If you want to count in millimeters, just make sure you times everything by 10, right? But if you want to go, like if something goes up to here, something goes up to this line right here, this would be 4.9 centimeters, or how many millimeters? Times this by 10, that'd be 49 millimeters, right? So either one is acceptable there. You can say that the precision based on this measurement is 0.1 centimeter, and the precision based on the second measurement here is 1 millimeter, but they're both correct. 0.1 of a centimeter is a millimeter. Both of these would be correct, so you got to kind of be comfortable with that. Okay. So this is the metric system. Metric system. You remember that from grade 10? 10 math, the metric versus the imperial, right? Anything that has a meter in it, meters, grams, milliliters, right? Those are all part of the metric system. Most of the world uses the metric system, except for our neighbors down south, right? And some other countries. We still, we need to put up with them because they're our biggest trading partner, right? We can't really tell them they're wrong, right? I'm just kidding. It's all good. Okay, next, imperial, inches, feet, gallons, ounces, miles. Anything like that would be considered the imperial system. You don't have to worry about that too much, to be honest. I just wanted to review this part. And I kind of already am telling you what's going to happen here. So before you write anything down, watch this, right? Just watch this. If you go from 0 to 1 or from 4 inches to 5 inches, there's something in between. And so what I suggest you do is to just count how many spaces. 1, 2, 3, 4, 5, 6, 7, 8. That means that this particular measuring tape, it goes up by 1/8 of an inch. So watch what I did here. 1/8, 2/8, 3/8, 4/8, which is also a half, right? 5/8, 6/8, 7/8, and then 8/8, obviously, when you get to the other side. So the precision of this measuring tape right here, just count how many gaps. It is 1/8 of an inch. That's the precision of this one. You need to be comfortable with fractions when it comes to the imperial system. The nice thing is it's always even numbers, right? It's always even numbers. Which means that the uncertainty of this thing would be 1/16 of an inch. Watch what I did. I just doubled the denominator, which is really halving this. Right? If the denominator goes up by twice as much, it's actually you're having half as much. So if it's 1/8 of an inch that you're going up by, uncertainty is 1/16 of an inch. Let's go to this one here. It's the exact same thing actually, guys. Watch. 1, 2, 3, 4, 5, 6, 7, 8. The precision is still 1/8 of an inch. The uncertainty is plus or minus 1/16 of an inch. Okay. I actually should have done this differently. I wanted to erase these markings here, so that if I did that, this would have been precise to 1/4 of an inch, because you go up 1/4 at a time. I don't know if my fingers make it worse there, but anyways, next time, if you take Essential with me next year, those will be gone. Anyways, why would you, right? I want to get out of here, Mr. Dixon. Anyways, this one back here, 1, 2, 3, 4, 5, 6, 7, 8. And it'll be another 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So this one is precise to the nearest 1/16 of an inch. And watch this. What happens to the denominator? You see that? It's twice as much. So your uncertainty here is 1/32 of an inch. Watch this. If you don't like fractions at all, you're like I'm having flashbacks or I don't know, nightmares. You can do this. 1 divided by 16 is 0.0625 of an inch. Let's divide that by 2, shall we? Divided by 2, you get 0.03125 of an inch. It's okay to do it that way. Watch this. If I go 1 divided by 32, you're still going to get this, right? So just go 1/16. You need to be able to do this much. Divide it to get your decimal, and then divide it by 2 to get your uncertainty. So whatever works. It doesn't show up that often, to be honest, and it's going to be either an eighth, a quarter, a 16th, a 32nd. It's one of those, right? But you can always turn it into a decimal. You're okay to do that in my class, okay? Let's keep going. This is just review, just in case it pops up here and there. Oh, and it does pop up. Page 19. So watch what it says. For each of the following, state the measurement like this with its uncertainty, and then tell me the minimum and maximum possible values for this bar that we're measuring. So watch this. You gotta look close. You gotta look close. I did this on purpose. Okay. This thing. Which one is it closer to, this one or this one? It's definitely closer to this one, right? To this line right here. Do I need to zoom in? It is closer, so if it's in between, pick the one that it's closest to. If you want a magnifying glass, bring it, right? Anyway, so this would be this right here. I'm going to say is the measurement would be 3.8 centimeters, or you want to do millimeters, so times it by 10, 38 millimeters. You got to be careful. I get tricky. I sometimes have this bar show up somewhere in the middle. So you got to watch out to not fall for that, right? I'm going to do this. Somewhere else on this piece of paper, maybe here, I'm going to state that my precision is 0.1 centimeter, right? And what's the uncertainty? Half of that, right? Which is plus or minus 0.05 of a centimeter. But I'm going to box this in. You can also say that the precision, I prefer to just say my precision is 1 millimeter. I base it on this number here, guys. It's to the nearest millimeter. And the uncertainty is therefore plus or minus 0.5 of a millimeter. So I don't always show that I'm dividing by half, right? It's just at first to get you going. So I will take this uncertainty, I will match the units, even though it's okay to have different units here, as long as you state them, okay? I like to have them the same. So down here it'll be 0 plus 0.5 of a millimeter, okay? So I'm going to make an arrow like that. You choose. And now it's asking for the max and the min. I'm just going to use one of these, not both. It's too much, right? So I'm going to get my max out of this, and I'm going to get my min out of that. And the max is simply 38 plus 0.5. That's 38.5 millimeters. And the minimum is 38 minus 0.5, which is 37.5. So this answer is B. I'm just going to put B. And this one here would have answered A. One of these does the trick. Why so complicated? Why two different ones, Mr. Dirk? So because when it comes to a ruler, it is a fact that you can do it in various ways. Okay. So do the one that works best for you. Do you want to stick with centimeters? Do you want to stick with millimeters? It's up to you. Okay. I want you to try, remember, attempt, right? I want you to try the two that are underneath. If you make a mistake, big deal right now. You're not going to lose any marks, right? So I want you to, first and foremost, state the measurement that you read, plus or minus its uncertainty. Like state the measurement like this. You might have to do some work beforehand, right, to make that happen. And then give me the max and the min, okay, for both of them, B and C. And we will continue this in a couple of minutes. Don't be shy, don't be scared, even if you feel exams. You're not going to write a provincial exam, but we're going to make an exam which is kind of in line with the provincial. So technically, you should still be prepared for that. And if it's in between, I will never take marks off if it's very vague, because sometimes when I print it, it comes out different than how it's on my document, right? So which one would you say this one is closer to? I'm going to go with 1.5. Yeah. So this is obviously in inches. So if, I don't know if you want to count ones somewhere 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So there's 16ths. That's my precision for sure here. So I'm going to say that precision is 1/16 of an inch. My uncertainty is plus or minus, what is it? 1/8? No, 1/32 of an inch. But let's say you don't like that. I always forget what the decimal is, okay? So I'm just going to say 0.0625 of an inch is my precision. And the uncertainty would be half of that, just 0.03125. Do not round, okay? Okay, so this is kind of like the work that happens in the background. And then you will state the measurement plus its uncertainty, plus or minus its uncertainty. So the measurement, I would say 1.5 inch plus or minus 0.03125 of an inch. And you're like, that's weird. Couldn't you have done this, right? Or you can go 1.5, right, inch plus or minus. I will go 1/32 of an inch. That would also be acceptable there. Doesn't happen very often, but it does show up from time to time, okay? So I'm going to use this one here. I feel like a lot of you are going to just prefer that. So to get your max from it, just go 1.5 plus 0.03125. And that gives you 1.53125 of an inch. And the minimum is 1.5 minus that. And there I need help with, because it's Monday morning. 1.46875 of an inch. So this is the min, and this is the max, okay? You want to do fractions? This can be rewritten as 16/32, right? 16/32. and then you add that, that'd be 1730 seconds plus, right? But I'm just going to leave it like that. If you know how to do that, you're okay. Okay, this one, which one is this closer to? 20 or 10? Obviously 20, right? So the measurement for A, right? The measurement is 20 centimeters, plus or minus, there's some sort of uncertainty. You have to go by the ruler. What's the precision of this ruler? How much am I going up by? 10, 10, 10, 10. It's 10 centimeters. And therefore, the uncertainty is half of 10, which is plus or minus 5 centimeters. See how that goes? We love metric more, right? Obviously, no fractions there. But this is based on ruler, right? It's based on the ruler where you get your, when there's a diagram, you take it out of the diagram. So it's plus or minus 5 centimeters. So to get the max for B, right? To get the max, we would just go 20 plus 5, which is 25 centimeters. To get the min, we would just go 20 minus 5, that'd be 15 centimeters. And I know it's an exaggerated example. You would probably be like, well, I'm going to guess that this is 18 or 19, right? That's your first instinct is to do that. Don't. Just go by the markings because it's kind of like just emphasizing the concept that we're trying to cover here. Imagine this is a digital device that can only do 10 at a time, right? And so you're stuck with that. Okay. I feel like rulers throw you off a little bit, but that's okay. We'll do, let's do other examples that don't involve rulers necessarily. But I'm now gonna, I don't know, I feel like I'll do one more and then I'm gonna call it quits. That's gonna be it for today, and then it's on you to do the rest of this worksheet, okay? State the measurement and the uncertainty. No ruler, right? So we're just gonna go with this. You can write down Celsius at the top. Quite frankly, a thermostat that had 22 Fahrenheit would be pretty cold in there. That's probably like a freezer. Celsius. So the measurement is 22.5. Based on this, right? What's the precision based on this number here? It's 0.1 of a degree that this is. Imagine this. Based on this device, you could go lower by 22.4. It's hard to see, right? Or it could tell you that it's 22.6. That's all we have. That's all we can go by. So the precision of this device is 0.1 of a degree Celsius. The uncertainty is 0.05 degrees Celsius. We divided this in half to get that. So the measurement is 22.5 degrees Celsius plus or minus 0.05 degrees Celsius. This is what they want right here. And you got this and plugged it in there. So there was no ruler to go by, we just have a number to go by. And we're assuming that it's going up by 0.1. Until you actually press those up and down buttons, you don't know. So we're going to have to assume that it goes up by 0.1. It could be going up by 0.2, it could be going up by 0.5, we don't know. So just go by the number, okay? Then the max is 22.5 plus 0.05. The min is 22.5 minus 0.05. So this would be 22.55 degrees Celsius. And this would be 22.5 0.45 degrees Celsius. If you use your calculator, right, you got to know your decimal places here, right? So your max and the min would be that. And the rest I'm going to leave that up to you. I'm going to post the key, and you're going to make sure you correct it. I will, to be fair, tomorrow probably go over, if you have questions, I'll go over some of them, but make sure you try them. Even if you get them all wrong, you might see it as a defeat, right? It's like, oh my goodness, there we go. Don't see it that way, right? You're going to learn from it, and I'm going to correct it, and you're going to start to see a pattern, like how do I deal with these scenarios? Because once you've seen all of these, I have so many examples here. I don't have more. I'm just going to have to like tweak it, do something a little different to it, but the basis stays the same, right? Okay. That's it for today.